Hi, everyone, and welcome back to Outspoken Market Global. Andrew Guerra speaking. In today's class, I'm going to teach you how to time your DCA entries with machine learning. Let's say you already have a portfolio. You already have selected the assets that you buy regularly, weekly, monthly, it doesn't matter. But you are disciplined and you have been buying it, thinking for the long run. However, we know in the market we do have moments that are particularly anomalous, that they might be opportunities to boost, to improve your entries, not only the ones that you have been doing already, but some extra. And the idea of using machine learning here is to measure when we have these moments that we can even call them anomalies, and we could perfect time better the entries in our portfolio. We can do this precisely like the example we have now in this chart using an algorithm known as isolation forest that I'm going to enter in the details in the next minutes. But here is an actual example with the S&P 500, or you could be using SPY, SPX. This is the example using the CFD that it's not recommended for long-term portfolios because you will have overnight costs. So it would be more interesting if you buy one of the indexes. But anyway, it's representing the S&P 500 and the idea of our class. And then you can see on this daily chart that we have since 2021 to the present day that we are recording this class, several points that they have been considered by the model optimal moments to boost your DCA entering. And some of them, I would say that they were close to perfection. And we will also understand why eventually here the model said nothing, or also here, or here, for example. At this point, it's clearly understood that it doesn't matter, but we might have had other opportunities as well. And the point is, remember, the objective of this class, it's not about trading. It's about I have been buying weekly, monthly, the S&P represented by some of the indexes, and then when the model realized that we had such opportunities, I could use it to boost my allocation. And this is a single example with just one security. You can apply this to every single one that you have in your portfolio. You can even go further. That would be slightly advanced if you're not so familiarized with coding, but you can transform your portfolio in a single asset by balancing and weighting and making some few mathematical calculations and have this its line, and then you buy everything at once. But this might be the subject for another class. For today's class, we have that representation with a single asset that can be expanded. The algorithm that we are going to use, it's the isolation forest. There are several machine learning algorithms used for anomaly detection. Why I'm picking up this one? Because computationally speaking, it's fast and it's efficient, and we like to keep things simple. So the results that you may achieve using only this algorithm, they are enough for the use case we are describing right now. So you don't need to overcomplicate these things. Now, the idea of an isolation forest, as the name suggests, let's make one step back, thinking about a decision tree. A decision tree will eventually get your input data and it will grow a tree that will help you to take the decisions. Each one of the pieces of the tree, let's put that way, they will be representing the ones with the highest information gain, for example, or pointing out the highest probability of a particular event if you are speaking about a classification problem. If you have a bunch of trees, you may have, for example, a random forest algorithm. Now, the isolation forest, as the name suggests, will be a forest, will be a composition of several trees, but instead of grouping all of the final points, the records from your database, towards a final node in order to give you the optimal decision, the idea is let's find not the normal data points, nor the data points that will be the ones with the highest probability of something happening. Let's isolate the ones that are different from the others so I can say that, look, there is something going on over here. And this, it's our anomaly that in our application would be the cases on which the market has been the most stressed. And then it's when you should think about giving an extra boost to your portfolio. It's beautiful. And this is what you should know. The mathematics that goes beyond that algorithm, it's actually really, really nice, but it's not the scope of this class. Now, let's deep dive into the Python code so we can understand how that was built. Here, Python in a notebook with cursor, you can pick up the IDE that you like the most. This is not important. We just need a place on which we can run Python. And I will be using to getting the data, the TV data feed library, so I can get from the broker that I use mainly for trading, but that I, as I said, don't be attached to, oh, it's just for the US 500 on capital. No, 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 no. And this is not a publicity, and I have nothing to do with them. It's just because it's the one that I use the most for trade. But the point is, I can get some data from here, and then you can do the same for your broker with the asset that you prefer. Now, I will be collecting the data from here. So what we need at first is have the run of this function that will just check if the main libraries that we are going to be using, like the TV data feed, Plotly, and scikit-learn, to run the isolation forest, they are already present in your computer. Then we are going to import the libraries. NumPy, Pandas, TV data feed, sklearn, and Plotly. From the sklearn, we will get the isolation forest and the standard scaler. Now we get the data from the trading view. We are using the no login method, so it's free. But if you're working with more real-time data, you will not have it. So if you have a TradingView subscription, you can do the login with your username and your password inside the method TV data feed that we are initializing here in a variable called TV. And then we get the getHist method on which we have as parameters the symbol, the US 500, the exchange, capital con, the interval, that in our case is daily, and the last 3,000 trading days. Then we do a basic data validation just to check if we had some data returned from TradingView. And if we can really confirm the connection has been established, we keep only then the clean data, making a copy of the data frame and dropping DNAs, just to be sure that our index is sorted from oldest to newest. We reset the index and sort it out here. Now, eventually you can you can skip that step. You don't need to keep it, but it's a little bit redundant, but I will leave here as an example for other situations you may need. Now, we will keep just the last 3,000 rows to be sure. Again, this might not be needed, but in the case the API returns more, we can have the filter done, and we just check the number of rows that we have. Now, in order to do the timing entry in the way I described it in the theoretical part, we will do a little bit of feature engineering, getting some market behavior features, very basic, like the log of returns, the absolute return, the 5 and 20 days volatility, the distance from the 20-day moving average and from the 50-day moving average, as well the intraday range relative to close. Now, remember, in machine learning, in mathematical modeling, features are the entities that will represent the phenomenon that you are studying. So, feature engineering is more important than the model itself. The better you do this step, the better are the features that you have, assuming that your entry data is good enough for your case. Otherwise, you have another problem because the data, it's even naturally more important than the features. But in our case, there is no, if we have the data, it's hard that we'll have any issues over here. So we can focus in the features. And focusing in the features means do some engineering that will create these good attributes. As I said, they are basic ones, but you can, and then you, not just you can, you should think about other features so you can improve your model and go beyond the suggestion I'm making. So I create here seven, actually nine different features from the description that I gave. Then we select them into a list that will be our feature columns. And then we split the model into training and testing. The training part will be half of the data. Now, I know that some textbook and some teachers, professors, they say that, oh, you can do 730 or 80/20. I'm not a fan. I like to stress the model and do it half. Just in the case I'm achieving no good result at all, eventually I will change that proportion. Otherwise, I like to do this to ensure that I have, at least from the very beginning, a sign of robustness of my model. So, splitting in half, the first half is my training, and the second half is my testing. Then I prepare the model inputs, scaling it. It's important to highlight, and I wrote here for you, that scaling is not mandatory for isolation forest, but eventually, if you want to try out other algorithm, it will be a good practice. So I leave the code over here. You will split it, and then you call the standard scalar method, do a fit transform in the training, and then do a transform in the testing. Now, that piece over here, it's the isolation forest model. We have essentially two key parameters: the number of estimators, that will be the number of trees that we will be growing, and the contamination. When I first wrote this code, I was using 3%, but I found better results with 5%. So this is my contamination. It's the expected proportion of anomalies in the data. You can play around either with the number of estimators and with the proportion of contamination. The random state is to ensure reproducibility, and then the max samples I will leave here as auto. Then we fit our model. So you see, fitting the model, training the machine learning model is this line of code, essentially. Quite easy, isn't it? Of course, there are all the mathematics behind it, but again, is that line. That is why I always emphasize that the most important piece, the one that truly requires the knowledge from the human behind it, is the feature engineering piece. Good. Trained the model, I will simply take a look on how it is looking like. Yes, here I will be eventually cheating a little bit because I'm plotting to you directly the testing set only. But I'm doing no changes into the parameters, coming back and forth, trying to optimize my model. I'm just saying that, look, I have this, and that might be good enough already, and it looks good enough already. If you want to be playing around with the parameters of the model and then with the features, you should always look to the training piece and then do this only with the training. Eventually, you may have training and validation and get some testing as out of sample, but remember, this is what you should do. Otherwise, you are cheating. Here, since I'm not doing this back and forth, as I said, I can look at the testing only. And we have very decent results. This is the baseline, my friends. It can get more complex than this, yes. Can this already be enough for good results as well? Yes, indeed. How's that? Come here. Let's pick up, for example, NASDAQ, US 100 in this broker. And let's run it again and see how it works, right? Don't remember, no, I have not parameterized the title. Let me just put 100 here as well, so we have things consistent. Now, of course, Nasdaq follows, there is a correlation with the S&P, so you will have some elements that are similar as well. But you have seen that the same configuration works as well. Now, how cool would be if this X, the red axis, eventually they are not your buying day? And then there is this anomaly. You have optimized your purchase several times throughout the past, I don't know, 6, 7 years. And well, now it has been pointed out last Friday as an anomaly, and indeed it was. Now we are coming even a little bit down than that. It could be that we are entering a phase like that. We don't know. We don't care. The future will tell. Because if you are a trader, there are other things to be doing rather than isolation forest to detect the anomalies. Then it's another thing. For example, the OMQS model. By the way, the codes, or actually this code, will be available in our blog with the title the same as this class, so you can check it out, and we will leave the link here in the first comment so you can get in there and do the download. And my point is, you see, it works, right? Even for Nasdaq. And then again, I'm doing minimum feature engineering. The more you do in the right way, of course, the better. Now, to close the class, I just want to point your attention to another thing. And here, maybe we are slightly shifting a little bit for trading. You can do the same stuff, exactly the same, but with the volatility. Now, if I do it with the volatility, uh, take a look. How cool is that? All the dots, they are exactly the same, not entirely, meaning that not all volatility points are the same as the ones from the historical closing price. And more importantly, not all volatility dots, they will be the same. This was an anomaly, and this was a lower volatility point than that one, right? That can be again improved with better feature engineering. But the point is, you see, this is another way of also representing the market stress. But if you are trading options, that algorithm for detecting anomalies, it could be a blast. Pretty cool. Because you can take the realized volatility, that is what we have here. If you have the historical data from your implied volatility, you can also get from here. Combine them, and when both are eventually showing opposite directions, you can make maybe a calendar spread among other options or structure operations with options. But then this is a subject to a future class. All right, my friends, I hope that was informative, that you have enjoyed it, and we can carry on that discussion even further. Join our Discord group. The link is also here in the first comment. And if you have any doubts, suggestion for a new class, just let me know and see you next time. Trade safe, keep things simple. Take care. Ciao, ciao.